All right, let's kick things off with a real head scratcher, a puzzle that seems to just break all the rules of common sense. It's one of the weirdest, most fascinating questions in everyday physics. It all starts pretty simply. So just picture this. You've got 2 cups of water. One's hot, one's cold. You stick them both in the freezer. The big question is, could the hot water, the one that has way more heat to get rid of, actually win the race to become a solid block of ice? I mean, it just sounds wrong, doesn't it? Your gut tells you the colder water, with its massive head start, should freeze first. Every single time. No question.
And this is the incredible part, it's not just a myth, it's a real thing. If the conditions are just right, the hot water absolutely can and does freeze faster.
And this bizarre little phenomenon actually has a name. It's called the Mpemba Effect. For decades, it's been this nagging puzzle that has totally fascinated and honestly stumped scientists trying to figure out how it works. So where did this idea even come from? Well, the story doesn't start in some fancy, high-tech laboratory. Nope. It starts with a high school student who was just trying to make some ice cream. So picture this. It's the 1960s, and a student in Tanzania named Erasto Mpemba is in a rush. He puts his hot ice cream mixture into the freezer, and what do you know? It freezes before his friends who started with a cold mix. Of course, his teachers just blew him off, told him he must have been mistaken. But Mpemba knew what he saw, and he kept asking about it. And eventually, scientists ran the experiments and proved him right all along. Okay, now for the million-dollar question. Why on earth does this happen? To get to the bottom of it, we're going to have to play detective and look at 4 key scientific clues. You can think of them as the prime suspects in this whole mystery. So here's our lineup. We've got evaporation, that changes how much water is actually there. Then there's convection, that's all about how heat gets out. We've also got dissolved gases, which affects the water's purity. And finally, a really strange one called supercooling. All right, let's look at suspect number 1, evaporation. We all know hot water makes steam, right? Well, that steam is literally water escaping into the air. So the hot water is actually losing mass. And if you have less water to freeze, well, it's a smaller job. It's going to get done faster. Simple as that. Our next clue is convection. The best way to think about this is like the water's own internal cooling system. In the hot water, you get these really powerful currents going. Hotter water rises to the top, cools off, and then sinks. This constant churning is super efficient at getting heat to the surface so it can escape. The cold water, its circulation is just lazy. It loses heat much more slowly. Okay, suspect number 3 is a little trickier. Dissolved gases. You see, cold water can hold on to more dissolved gases, things like oxygen, than hot water can. The act of heating water actually kicks those gases out. So the theory goes that water with fewer of these little impurities might just find it easier to form those first ice crystals, giving it a slight advantage in the race to freeze. And that brings us to our last and weirdest suspect, supercooling. This is a genuinely bizarre thing water can do. Sometimes, cold water can actually drop below its freezing point, below 0 degrees Celsius, without turning into ice. It stays liquid. Hot water, for whatever reason, seems less likely to do this, so when it hits 0, it just freezes. Meanwhile, the cold water might still be stuck in that weird liquid state. So there we have it, 4 suspects. Case closed, right? Well, not so fast. Turns out, this whole phenomenon is incredibly finicky. The crime scene itself, the environment, plays a massive, unpredictable role. And that's because so many little things have to be perfectly aligned for this to work. I'm talking about the shape of the cup, the exact temperature of your freezer, how the air is flowing, how pure the water is, even the precise starting temperatures of both cups. All of these things can completely change the result. This is exactly why the Mpemba effect drives scientists crazy. You can tweak just one tiny variable and poof, the effect is gone. It's so sensitive that creating a single foolproof experiment that works every single time has been almost impossible. So, after looking at all the evidence, the lineup of suspects, the crazy, unpredictable environment, what's the final verdict? Can we finally crack this beautiful, unsolved mystery? So what is it? What's the one, single, definitive reason this happens? Well, the truth is, there isn't one. After all this time, there is no single explanation for the Mpemba effect that everyone agrees on. You see, instead of one single culprit, it's more like a conspiracy. On any given day, it's probably a combination of these things working together. Maybe evaporation gives the hot water a head start by losing some mass, then convection takes over to cool it down super fast, and then its refusal to supercool seals the deal at the finish line. And that's what makes this whole thing so cool. It's this perfect reminder that something we think is so simple, so ordinary, just water, is actually behaving in these wonderfully complex ways, with all these secrets hidden just beneath the surface.
It really just shows you how subtle and surprising nature can be. And sometimes, just like a curious student named Mpemba proved, all it takes is a scoop of ice cream to uncover one of its greatest little mysteries.